Okay. Hi, my name is Jason. I'm one of the members for the Casino Royale game for the CSCB58 project.
My name is Usman, and we worked on this where we created 5 mini games.
My name is Kelvin.
Hi, my name is Robert, and I'm also part of the Casino Royale group.
So I'm going to start off by talking a little bit about our project. So in this project, we thought about choosing other modules to improve on, but we decided to take the challenge to do this all from scratch and create our own modules with hierarchical design in mind. So the first game I'm going to talk about is roulette. So essentially the goal of this game is to have the player choose a number between 1 and 10 and bet that a random number generator will generate that number. So the player plays this by using the switches 4 to 0 to choose the number that they want to bet on, and once the number is chosen, you press key 2 to generate a random number and compare against that number that the player picked. So if the player wins, then the hex screen will be updated with the score of the player, and on the right side you'll see the random number that was actually generated. The max score of the player goes to 30 and the lowest score is 0, so that's when the game essentially ends.
Okay, so now I'm going to do a demonstration of the game roulette. On the left 2 hexes, you see your score. On the right 2 hexes, you see the random number that's generated. So I'm going to use these switches to choose a number. So for example, 3. I'm going to press key 2, and then you can see that 3 was generated. So if I press this again, it increments by 4 because that's the number of points you're awarded, and that number, random number, was 3. So if we choose a different number, say 7, and we press key 2, we see that it decrements the score because the random number generated is not equal to what we chose. And then if we want to reset, we press key 2 or key 0.
So our next game is roulette, even or odd. It's similar to roulette, instead you choose whether to guess even or odd. Instead of getting 4 points, you get 2 points for winning now. Okay, that's good enough.
Yeah.
Okay, so now a demonstration of even or odd roulette. Switches 0 toggles between odd and even guess. If it's down, it's odd, and up, it's even. Okay, so to start the game, I press key 2. It was an even number, so you get a point for it. And I'm gonna guess odd. So it's not odd, so I'm losing points. That's gonna be even. It's gonna be odd, so I'm gonna gain 2 points. That's it.
Okay, so basically I will be demoing the slots machine game. So to go to the game, you have to switch 7 and 9 up, which will use a mux to go to it, and key 3 represents this hex display, and key 2 represents this hex display. So when you press both of them, it resets the values. And so let's say I want 4, or let's say I want 7, and I want to get this value to 7 now. So when I keep pressing it, I am gonna try winning the game by getting the same value on this side. And if I get the same value on this side, it will turn the LEDs on.
Well, most of the time it seems to.
I'm gonna change my value so I can maybe win.
Fucking code snake and like Python, I'm gonna like just remember like how to read
There you go. Since I got 10 and 10, the LEDs turned on. So that's basically the slot machine.
So our final game is a battle 1v1, where basically you have 2 players and they press key 2 and 3, and they try to get the higher number from a random number generator.
And the display, it shows it on the display which number it corresponds. So key 3, which I am,
would show the first hex display on the left, and then key 2 represents the second hex display on the right. And then if you have them pressed at the same time, you see the numbers change, and then one of the player has a higher number and they win.
Now a demonstration of blackjack. To toggle into the blackjack game, switches 9 to 7 will be 0, 1, 1. And I'm going to reset the game by pressing key 0.
But whenever we tried that,
okay, key 3 would give the player 2 cards and the dealer 1 card to start.
Like it would still crash into the wall when you pick
So
up.
now I am in a losing state now because
So we tried a
LEDs
different thing, which
9, 7, and 5 are on, so it means I lost.
8-bit values.
I'm gonna reset the game again and
And add a 0 in front, and that fixed most of them. But some of them still
as you
spawn
can
outside.
see, it's not working properly, but
most of them
some
still
it's
spawn
because the addition is not
So that's a
working.
positive.
Yeah, so only some parts of this
Border collision,
game
border collision,
for blackjack
so,
work.
the
So
three main
we'll just show you the logic behind it, I guess.
So blackjack doesn't fully work on the heads display, but we'll show you the logic behind it. Okay, so here's the code for the
the
blackjack.
working thing was supposed to be that we
We
delete
have
it and
a
then the
random
next
number
one's twice.
module
But for some
that
reason the delete
keeps
wasn't
running,
working, so we
counting
just
1 to 10, so it
that's
looks
that.
like it's flashing
Let me
for
try
the
to get
output.
the output collision.
And here's the finite state machine for it.
There you go.
So
Okay,
it starts
it's spawned off
at
screen. One more
state
time.
0,
one more
0,
time.
0. If
I-
the player
if
presses
border collision,
enter,
it
which
comes
is
back.
key 3,
So it's this one.
2 cards are added to a player and 1 card to a dealer.
And yes, it just randomly breaks it.
Then it goes to
That's
state
that.
1.
I'll also show. I'll show you
If
something.
enter is pressed again, then another card is added to the player. And if the player stops, then they can press pass, which is key 2. This would give the dealer 1 card. Both players continue playing until they bust, hit 21, or the dealer has a higher card than a player.
Let me do the Apple one more
So
time.
here's the player losing
It is
state.
this one.
The finite state machine would
Right?
show the
That's
LEDs
how it's supposed to be.
10101.
Okay, so when we're coding up our project, we made it so that each of these games had their own finite state machines, and these would include like the initial state, the winning state, losing state, and this would essentially help direct the logic and the flow of the actual game when a player hits like a key, for example. For a random number generator, it was pretty much the basis of most of those games. How it worked was that it was pseudo-random, so you have the numbers starting from 1, counting all the way to 10 at a very fast rate. So what would happen would be the player essentially presses a key, and then at that point when the key is pressed, that particular number is selected to be the random number.
This is our finite state machine for the roulette even odd game. So essentially what you have is your initial state here with your initial balance as 10, and then if we hit the key to start the game, then it's going to take you to state 01. In this state 01, that's when we're comparing that random number we got to check whether or not it's odd and to see if the player actually guessed odd, or if the random number was even and if the player actually guessed an even number. So this increments the balance for the player. If the balance is over a certain amount, then we take the player to a winning state. And then here, if the player didn't get the right guess, then they lose $1 from their balance. And then if the balance is equal to 0 at the end, then we take them to the losing state. And then these just allow the player to restart the game.
Again, explain the MUTs module. So inside the MUTs module, every game is instantiated in there, and it toggles between the output for each one of them.
Yeah, you can make the clock speed faster or slower if you
So
make the game easier or
the
harder.
switches
Or you
are
can just make the pixel
101 for slots, 000 for roulette, and so on. Each game can have 4 outputs and 1 LED output, and that's what the MUTs does. Just chooses which one to output to. And here's a demo of the MUTs.
Yeah.
So here, 101 would be the slot machine game. 000 is roulette. 001 is roulette even or odd. 1v1 is 111. And blackjack, which isn't working, is 0111.
Okay, so how future students can build on what we created is they can use our random number generator for any other types of games. They can use our MUX to create more mini games and switch between them. They can add a VGA module, as we didn't have that, so they can actually take this whole casino thing and add a visually pleasing layout and like expand on what we created. They could also fix our blackjack, or create any other casino related game that they really want to do. So that's about like what they can use. And yeah, that concludes our whole presentation of the CSCB58 project.